Hi there. In this video, we will learn about how to find out what process or what set of processes have opened a particular file. If at all you want to find out a list of files being opened in your entire system or list of files opened by a process, you can use lsof command. You can also find out find out what files are opened by a given process or system wide without using lsof. I've done a video for that already. You can have a look at that video from my playlist in Linux command line. But then sometimes you have a file on disk and you might have one of the process that has opened the file. And how do you find that out? One of the easy way to find out is by using a tool called fuser. The fuser tool lets you monitor a process or look at a particular file and find out which all process opened it. For example, I have a lot of files in here and I know this file is being opened by one of the Python instances here. So you can see this. I've said in file is equal to open of testfile.txt. Now, if you want to find out what process opened a particular file, you can actually say fuser and say testfile.txt. It will report the process ID of the given process. The process ID of this Python instance, if you want to find out, is 93756, which matches it in here. So this is one of the ways you can find out. So you can look for what process is actually using a file, open it, and maybe performing some read or write operation if necessary. So if at all I want to look up any system-wide files, let's say, let's look at a file like say /var/log. There's a lot of files in here. So let me try out maybe system.log, syslog. So I'll just try to say fuser /var log syslog. Sometimes you don't get any output. It means two things. One possibility is that you don't have permissions to get those details because you're not running as root user. So let me try to prefix sudo for this. You can see that syslog has been opened by a process with PID 1387. You're going to find out which particular process corresponds to 1387. Let me do a quick check here. 1387. You can see it's rsyslog-d. So you can find out what process has opened a particular file. Sometimes you can also use the fuser command to check whether any process is using a mount point. This is very, very useful if you want to deal with removable devices. Oftentimes when you plug in a pen drive and if some command has some program or some utility is using a file in a pen drive, you will not be able to safely unmount it. Try unmount command, it will tell you that device is busy. This can happen if you're dealing with external storage devices. In such cases, you can actually try using fuser -m and you can just try the mount point. So you can just say something like /run media, whatever, /run, maybe I can just try, or I can say /media /moonranger whatever the pen drive is. So you can actually find out which particular process is utilizing a pen drive by treating the entire folder as a mount point, looking up all the files underneath it. So it looks like if you look for /media /moonranger, it treats it as a mount point. It can show you, it shows so many processes are dealing with files inside this directory tree. So which means that I need to terminate all these processes in case I want to unmount this particular mount point. If it's a mount point, that is, right? So you can also kill all the processes that is using a particular file by using fuser -k. Use this with caution, it will deliver a kill signal. I want to try that with Python in this case. There's a Python instance running here, right? So if I say fuser -k and say testfile.txt, just see what happens with the Python instance. It actually got killed. By default, it delivers a kill signal to processes that is using a file. Remember, kill signals are signals that cannot be cannot be ignored, cannot be caught. So the process is force killed. It's like running a kill -9 switch on this particular process. But maybe you don't want to run a kill signal. You want to temporarily stop a process, suspend a process, because maybe you don't want the process to write or do anything with the file when you're trying to operate on the file. So you can actually do that. So let me launch Python one more time and just say import os and os.getBit shows the new process ID is 94448. And let me try opening this file one more time. I'll just say in file is equal to open of testfile.txt. Now, if at all I want to stop this process, suspend this process temporarily, and then want to resume it back, you can do that by using fuser minus stop and say test file.txt. This will basically suspend the process. This process now, okay, it looks like it has no effect. I think I had to give fuser minus stop. Maybe I should use minus k minus stop. Yeah, minus k is also required. Yeah, this process is now suspended. So you need to use fuser minus k and say minus stop. Just minus stop will not do. So this process is now suspended. It's not really killed. It's in suspended animation. It's in the stop state. So you can now safely use this file. You can be very sure that that process is not going to modify the file when you're trying to read it or modify. So if you want to have some atomic access to certain files, it could be very useful. And once you're done, you can actually use fuser. Sorry. You can actually here, I can just say fuser minus k minus cont continue test file.txt. But the process that has been suspended is now in a continued state. Okay, it looks like the process running the background. So that's what I can think of, because the shell is also running and the process running, maybe it's running the background. Let's verify that. We have interactive tools like IPython. It might be a bad idea. It's a background running process like syslog-d and so on. This might be very useful. So let me just verify that again here. IPython is in stop state right now. The problem is that it's not in the foreground. It's switched off to the background. That's a sad fact. So don't try this for foreground running processes, especially interactive tools like IPython. May not work very well. But if this was a background running process like a logger, one of the places I found this very useful is log consumers like klogd. In the early days of Linux, when I had to look up kernel logs, one of the ways you had to look up kernel logs in the early days of Linux was looking up a file called /process kmsg as root user. The problem with catting this file is that when you read the data, nobody else will get it. It's consumed. The logs are consumed from when you read this file. But there's already a process running called klogd that does just that. Klogd and rsyslog-d keep this file open and they constantly keep reading the data. So when they are reading the data, you'll not be able to read from this file. You'll not be able to get new kernel messages coming from this file. So it's like one producer, two consumer analogy. So if you consume the logs, it's not going to go to klogd. If klogd consumes the logs, you will not get it. In such case, if you want to temporarily, like say, suspend klogd, not read the log, there you could actually use this technique, fuser minus k minus stop, and just give the log file, because you don't know what the process ID of klogd is. So the very script friendly way is you just represent the file, then you can consume the log contents, and once you want to resume the klogd, you can say fuser minus k minus cont and test file.txt. But yes, these are stop and continue or signal names. To know what all signal names you can actually pass to fuser, you can also use kill minus l. All of these are signal names that can be safely passed on. You can see that I use cont for continue and stop for stopping the process. The same can be used by you, right? So if you really want to terminate the process completely, or you want to, let's say, gracefully terminate a process, you could use fuser minus k minus term and the file name. This terminated the process in a very graceful manner, right? So that's what you can see. So this is how you can use fuser command to control processes that is actually open a file. You can find out what process opened a file and you can control them accordingly. One of the useful commands or switches of fuser is if at all you want to remove a pen drive or remove any removable storage media, if you want to unmount it safely, if you believe some applications could be reading them and you want to terminate all those applications, then remove them safely. The way you do that is fuser minus km. Minus k is to kill all the processes, which is utilizing files in the mount point. That's what m is, and then provide the mount point. What are the mount pointers? /media, / your username, / the volume label or the volume serial number. You can autocomplete and check that. So this will make sure that all the processes and applications utilizing any files in that particular removable media, they're all terminated. If you want, you can, this will do forced termination. If you don't want to do forced termination, you can also use milestone. You'll try to tell these processes to gracefully exit, and then after which you can unmount the mount point, right? So this is how you can use fuser command. If you want to find out how to solve the same thing without using fuser, you can do it without fuser, but it gets a little more complex. It's just that, like in the previous video, I showed you how you can get to know the list of open files by navigating /proc. Even fuser does the same thing. It just does a little reverse. For example, Let me go back to IPython in here, and let me just open this file. As you should. I want to find out the process ID of a process that's opened this file, test file or txt, without using fusers. How do I do that? Well, you can actually do a search like this. You can just do a for fin /proc /0 to 9 star /fd /star. That's a do, and I'll just say file name. I'll say file is equal to $of read link $f. Basically read the symlink, get the actual file name. But I'll just do one thing. I'll just print the file name. It'll give the full path, but maybe I want to just get the base name of the file. So I'll just use $of base name $of read link $f for now, right? So I'm just going to use the file name alone. Yeah, this may not be the right thing to do because there could be test file or txt across in different folders, but I'm just trying to make things simple. Otherwise, you have to give the complete absolute path to verify, right? So if I just say echo $file this time, it's just going to echo that file for every single entry. Every single file is echoed with only the base name, right? You can see all the files are shown only with the base name without showing the complete path. So now here you can actually check whether that file matches what you're looking for. So if it matches, let's say I could actually say if $file equals test file.txt, then you could actually use echo $file one more time. And you can also, I'll just say echo $f. I'll just print the full path, right? And okay, something's wrong. Parser. Okay, I didn't use then, is it? Yeah, I said then. Yeah. Writing a script completely inside can be a little cumbersome. So yeah, the done finished right here. So I'll say, if this is the case, hang on, I think I tried a shell script. Sorry about this. I'll just say sh, difficult to write, complex code inside a shell prompt. Use simple nano. Let's make it a bash shell script. Can be normal shell also, /bin/bash. And I can just say for fin /proc /0 to 9 star /fd /star do you want to get the file name. It's equal to $of base name $of read link $f. It's if $file name equals test file.txt. I'm hard coding things here. You can actually take it as shell parameters and improvise. I'll leave that as an exercise for you. Echo. I'll use $f this time. End with fee and done. Let me try to save this. This is a very hard-coded shell script. Checks specifically for a particular file and prints the actual path. So we just now, if you just try to say, oh, there are many places I think base name actually fails because there are places where there are spaces. When there are spaces, I think it sort of fails. We might need to fix this by putting base name $read link $f within quotes. Perhaps this might fix it. So it is a shell script, so it's going to be a little slow, but it tells you very clearly it is this particular process ID. Further, you could actually split this entire entity and get the second field, and that will give you the PID of the process that's actually opened this particular file. So if you want to verify that, it is 94802. You just say import OS and say os dot get PID. In fact, it is indeed the process ID of Python. This is a shell script which I simply wrote. You can further improvise it. There's a lot of scope to improve. One of the things I can tell you is you can actually take this as a command line argument. Instead of hard coding it here, you could actually take it as $1, right? So you can put $1 in here to get it as command line argument. And you could also split this particular $F, split it based on /. Maybe you can use cut command to split it and get the second field. Let me just fix that. It's not very difficult. So let me just. Search is equal to $1. I'm not doing any validation. You need to actually check, ensure that the script is passed with at least one argument. Otherwise, it has to payload with an error. So all those extra features you can add. I'll use $search in here. And here in this case, I'll use cut minus field 2 minus delimiter /. From $F. Oh, actually, it opened that file, right? Okay, mistake. I should actually say echo $F pipe. It was used like a filter. It's proc. I need to get $3 then. Because there's a first /, then there's second. So yeah. Mistake. Sorry, sometimes I try to switch to Vim editor, so that happens subconsciously. I just type VI very quickly rather than running nano, but fine. You can use nano VI, whichever you want. Yes, this is how we can actually find out what process is using a file without using the actual fuser tool. We were able to craft it using shell script. There's a lot of scope to improvise this, and yes, if you look at it, the performance is not that great. One scope for improvement is this. If you know that you're using bash shell, there's a more shorter way to actually have to avoid this. You can avoid this complete file name, getting the base name from read link. You should be able to do it in here. The search itself can be more optimized, right? If you do find out the more optimal way to do it in bash, you can just paste your code in the comments. So let's see how many of you are really good in bash. So yeah, and do let me know. So after a while, maybe I will also paste the more updated code on the comments. If I get a comment, I'll just reply back, and maybe if there's more optimal code, I'll paste it there, right? All right. So thank you all. Hope you find this video useful. So I talked about fuser command, but I also told you how fuser does this job internally. I just showed you in a very similar shell script, right? So thank you very much. So hope to meet you in future videos. Thank you.